Now we are going to another type of questions which is comprehension based. In this comprehension based type of questions, a small passage will be given. This passage is given from the area of stereochemistry. The passage goes like this: optically active compounds are those which turn the plane of polarized light. This optically active compounds can be existing in the form of enantiomers or diastereomers, or can also be existing as meso compounds. This is all the statement that is given. Based on this statement, three questions have been asked. The first question is given below. The first question says, which can exist as enantiomers? What are enantiomers? Object and mirror image, something which is optically active. So among this, which can be optically active has to be, in the other way of asking, which can be optically active, it has been asked which can exist as enantiomers. When you look at this, you will find this is the only one compound which can exist as an optically active compound, 2-bromobutane, because 2-bromobutane has got a chiral center which is like this. This is the chiral center. This is the center to which 4 different groups, this is a chiral carbon to which 4 different groups are attached. Therefore, this can exist as only one choice is correct. So obviously the other 3 choices are wrong, but we will go one after the other. The first one is A is 2-bromobutane, which has got a chiral center. This can exist in the D and L forms or the optically active forms. Therefore, this is correct. A is correct. What about B? B is not, it's a pentane, 3-bromopentane, it's a 5-carbon system. This is pentane in which 2 similar groups, CH2CH3, CH2CH3 and 3-bromopentane. This cannot be optically active because there is no asymmetry present in this compound. Therefore, that doesn't exhibit, that cannot exist as isomers or enantiomers. Now, D and L glucose, they represent only the configuration. D glucose represents the configuration in which the hydrogen is left at the chiral center, and L glucose represents the structure of glucose to which hydrogen is attached to the right. Therefore, D and L, capital D and capital L, they do not relate to the sign of rotation, they represent only the configuration, so they need not exist as enantiomers. So that is also not correct. Meso, as we actually know, there is internally compensated compound. Meso is an optically inactive compound. Even though there are 2 chiral centers, the optical activity due to each chiral center, mutually they cancel each other. So this does not exist in the form of enantiomers. This also does not exist in the form of enantiomers, and does not exist in the form of enantiomers. Only 2-bromobutane, of course, it's a very simple compound, exists as enantiomers because it has got a chiral center in the 2nd carbon atom. This is the first question based on this title.